Welcome back. In this lesson, we're going to look at the outer planets of our solar system. There's 8 total planets in the solar system. The first 4 were terrestrial. The last are the gas giants. So we're looking at Jupiter and Saturn and Uranus and Neptune. We're going to see that they have similarities and differences. Many of them have satellites, which are moons, much the size of Earth or even bigger than the Earth. So let's look at some of what we know. The 4 outer planets in the solar system are called gas giants. They're called giants because they're very big, and they're called gas giants because they are composed of light elements which are in gas form, primarily hydrogen and helium. So they are essentially gas balls similar to what stars are. Now, stars have so much gravity that they've actually crowded in their molecules so much that they're undergoing fusion, in which the insides of the atoms, or the nuclei of the atoms, are being fused together, and so hydrogen is actually being turned into helium with a resultant enormous amount of energy. So that's a star. Well, a planet could be made up of the same stuff a star is made up of. It's just that it doesn't have enough of it to have sufficient gravity to ignite. So if Jupiter were 10 times bigger than it is, it would be a star, just because of what it's made up of and the amount of material that's there. So even though it's light, it's still massive. It has way more gravity than Earth does because of its mass. The mass is based upon how much stuff is there, not what that stuff is. So even though it's very light, it's hydrogens, the smallest of the elements, it's still an element, and it's still matter, and all of that matter together has mass. And so you have gravitational effects of these planets. They have their own moons. Some of them have many, many moons. All of them have ring systems. So they're interesting and very, very big. So the first one is Jupiter. Now, Jupiter is the largest. So I think of it, if I go by tens, so it's 10 times is actually 11 times bigger than the sun, but I can remember 10. Jupiter's 10 times bigger than the sun, and the sun is 10 times bigger than Jupiter. So that gives you some kind of an idea of the size, the relative size. So 99% of all the matter in the solar system is occupied by the sun. Of the 1% that's remaining, 70% of that 1% is occupied by Jupiter. So Jupiter is more massive than all of the other planets put together. So for that reason, it's serious in its effects that it has in the solar system. It protects Earth because of its great gravity. And so we'll see that it's interesting in a lot of ways. One of the things you see if you just look at the planet through a binoculars or telescope is that it's striped. It's striped, and these are what you're looking at since there's no surface of the planet. These are all essentially clouds. It's a gas planet. So it's clouds that are spinning, and as it's spinning, you're going to get some that kind of move towards the outside, some that sink in towards the inside, and so you're going to have this striped appearance. So we'll look at that in a minute. Also, there is I should have picked a picture that had the dot. There's a huge red spot on Jupiter that essentially is a hurricane that has been going around for centuries. The earliest person to actually record it in a book was about 300 years ago. So that means this storm on the surface of Jupiter has been raging for at least 300 years. These planets have been, we've had probes sent to. So we've sent spaceships to it, not manned spaceships, but we have sent probes to these outer planets. And what was interesting is we just from Earth could tell that Saturn had rings. But it turns out that all 4 of these outer gas planets have rings, smaller than Saturn, but composed of some kind of rock-ice mixture. And so they're faint. There is a very strange atmosphere in Jupiter. You would think that since it's just gases, you don't really have an atmosphere because the entire planet is atmosphere if you want to think of it as a gas. But It's strange that mostly it's hydrogen, but because of its extreme gravity, funky stuff has been done to this hydrogen, and it's liquid rather than gaseous exactly in the core, and metallic. So it acts more like a metal than a nonmetal. Normally hydrogen is non-metallic, but it's acting strange because of just how much there is. I mentioned a moment ago the rotation, and as it's rotating, you're going to get bands of sinking clouds and bands of rising clouds. The sinking clouds are the darker areas on Jupiter, and these are called belts. The belts are towards the inside, and then the zones are these stripes that are rising. So they're sinking and rising, and they're different colored. In terms of the relative size, Earth could fit inside the spot on Jupiter, just to give you some indication. So along the diameter, you could fit 11 Earths along the diameter of Jupiter. So that gives you some idea. You've got Mercury, which is a third of the size of Earth, Moon, which is a little bit less than Mercury, just to give you some perspective. And then these are the four largest moons of Jupiter. These are called the Galilean moons because they were first spotted by Galileo when he made a telescope and looked at the moons of Jupiter, and it was this that made him determine that the heliocentric model is the only model that makes sense, because these moons are not going around the sun, they are going around Jupiter. He was able to determine that with his telescope, and these are the four that he saw. Largest is Ganymede and Callisto. These are all Greek mythology names. Europa and Io. And even though that the gas giants themselves, the planets themselves are gas giants, many of their moons are not, and you'll see that they are terrestrial just like Earth is. There are 69 total moons. I showed you the four named ones that I would want you to know: Ganymede, Callisto, Io, and Europa. Gravity assist is interesting in that if you go around Jupiter, it's going to pull you in because it has serious gravity. But if you come in at such an angle that essentially you can use Jupiter like a slingshot. So as you come into its gravity and then pull away from its gravity, you can actually be propelled away from the planet. And any thoughts of space exploration that would go past Jupiter, right now, that's what we're planning on doing. We're planning on using Jupiter's gravity to essentially go close to orbit with Jupiter, but not so far that we're getting sucked in. We're essentially flung out like a slingshot. The next of the gas giants is Saturn. Saturn is the one with the rings. It's so prominent. They stick out so much. You can see this just with a very wimpy telescope. You can see the rings of Saturn. All of these have had probes going to them. You can see, too, that since this is a gas, it has less density than water. So you could float these gas planets on a lake if they would fit. If you had a lake big enough to float Saturn in it, it would float in the lake because it's essentially gases, which is less dense than water. Interesting is the magnetic field of Saturn is way bigger than Earth's, and unusual because of what's in it. You're going to see that inside the planet, it does have hydrogen helium like you would think so, but you're going to have a small core inside Saturn that must be rotating because it has a huge magnetic field like the Earth does. The rings are essentially ice in rock, and some are the size of dust and ice cubes, houses, small towns. So once you get into larger rocks, you're talking about a satellite, and those satellites are called moons. So there's more than 60 moons in Saturn. Some of the moons are round and some of the moons are not. Some of the moons are very odd shaped, and there's lots of these that are named. But the one that's the largest is called Titan. Titan, another Greek mythology term. Mercury itself, he was the messenger of the. Saturn itself was a Greek god, just like Jupiter and a lot of these other ones were. So a lot of these come from Greek mythology. The next one is Uranus. Uranus is unique. It's got moons. It's got rings, like we didn't know before until we sent a spacecraft there. It's got rings, and most unusual about it is that its orbit is exactly 90 degrees to the equator of the sun. So its north pole is facing the sun, and its south pole is facing away from the sun all the time. So the sun doesn't rise and set because the sun is always at the north pole. The planet will circulate on its axis, but it will circulate on its axis without the sun being a reference. The sun is always at the north pole. Very strange. It's blue shape, or blue color, because of its methane gas. Essentially, it has methane atmosphere. The moons, there's at least 27 moons, and those moons can be Earth-shaped. And so as they're looking at these further moons, it's possible that we could land on these moons. Certainly couldn't land on Neptune, but you could land on the moons, or on Uranus. Neptune is the last one. And Neptune, again, Greek god. I think he was the god of the sea, god of the oceans. Wasn't found until the middle of the 19th century because it is massive. Even though that it's just gas, it's massive, and it will affect the orbits of things around it. So as astronomers are looking at objects and they're moving in unusual ways, a lot of reasons behind the unusual quality of an orbit is that something more massive is tugging on it and giving it a tug from another direction and kind of keeping it from going as fast as it should, or keeping it going from where it should. And so Neptune was discovered then. Now in the 20th century, other planets have been discovered. Pluto, Sedna was the 10th planet, very briefly there in the 1990s. Later it was just determined that there are so many of these planets past Neptune, and they're very small, that these are called now dwarf planets. They've been redefined. The atmosphere is dense, and it has rings just like the other gas giants, and 13 moons. The largest of the moons, really the huge largest of the moons, is called Triton, and Triton is a planet-sized moon.